today's notes and practice, we're going to continue our work with trig functions, in other words, SOHCAHTOA, but we're going to use them in a few more specific examples and not just in simple triangles. So we're going to go ahead and look at this triangle that we've got on worksheet B notes, and it asks us to find the value of x. So as I look at that triangle, if I look at x, I know that it belongs to one of two triangles. It doesn't matter which triangle you look at necessarily, except for you have to consider the things that you are given. So for example, if I looked at this triangle over here, I could find x except for I don't have any of the other side lengths in addition to that angle. And remember, with trig functions, I would need either a side and an angle or two sides, and we'll get to that a little bit later in our notes. So I can't look at this yellow triangle. Now if I looked at the blue triangle though, I do have an angle here, and I also have a side length 8. So now I need to figure out the relationship. So in relation to the 64-degree angle, I need x, which is opposite, and I have adjacent. So I'm going to go ahead, and please do the same, and write down SOHCAHTOA so that we can remember which function has which ratio. So once I have SOHCAHTOA, I know that I have opposite, or I need opposite, and I have adjacent, and so that's going to be the TOA part, or tangent. So we're going to take the tangent of 64 degrees, that's the angle I'm working with. I need opposite over, and I have adjacent. So now I'm just going to figure out that ratio. In my calculator, please punch in tangent of 64 degrees. Now just a little reminder that you probably should make sure that your calculator is in the degree mode first. So go ahead and take a second and hit mode and look at your degree versus radian option and make sure that you're in degree. So now that you've gone ahead and done that, now take tangent of 64 degrees. Remember, we like to round that to 4 decimal places, so that's going to be 2.0503 equals x divided by 8. I'm going to multiply both sides by 8. So 2.0503 times 8 is 16.40. And it's appropriate to round your answer to 2 decimal places. So I know now that this x is 16.40. I'm going to go ahead and jot that into my figure. So then it says, use what you know about x to find the value of y. So now I'm going to flip back over to this yellow triangle, and notice now I've got an angle, and I have the opposite side. I need the hypotenuse. And so opposite and hypotenuse would be sine. So in this case, that would be the sine of 48 degrees is going to equal the opposite, which is that 16.40, divided by hypotenuse, which is y. I'm going to need to go ahead and find sine of 48 degrees, which is 0.7431 equals that 16.40 over y. I'll multiply both sides by y, so I really have 0.7431y equals 16.40. I want y by itself, so I will take 16.40 divided by 0.7431. And y equals 22.07. Now I'm going to look at that triangle and see, does that make sense? And I think it does, because that hypotenuse is larger than that leg, or the vertical side of that triangle. Okay, the next question says, now find and label all unknown side lengths. So now I need to look at all of the things that I need to find. Well, I need to find this hypotenuse over here. That would be part of the blue triangle. And then I also need to find this other side length of the yellow triangle. Let's go ahead and find the yellow triangle first. So let's see, in relation to this 48 degrees, I have the opposite and I want the adjacent. Well, that's going to be opposite over adjacent, which is tangent. So tangent of 48 degrees equals the opposite, 16.4, over the adjacent. I'm just going to call that little a, just to give it a variable. Find the tangent of 48 degrees, which is 1.1106, equals 16.4 divided by a. Multiply both sides by a, and then divide. So that would be 16.4 divided by 1.1106. Therefore, a is 14.77. Now just kind of checking to see if that makes sense. This angle up here in that yellow triangle would be whatever 90 plus 48 from 180 would be, and that would be 42. Well, if I think about those side lengths, the angle across from the 42 is going to be a little bit smaller than the angle across from the 48. Just because of that opening of the angle, as it gets bigger, the side length across from it gets a little bit larger. So that makes sense to me. So let's go ahead and now find that hypotenuse on that blue triangle. So if I switch over to the blue triangle, I notice that I have 64 degrees. I'm going to use this 8 because that's the one that was given to me. So that's adjacent over hypotenuse. And I know that adjacent over hypotenuse is cosine. So I would go the cosine of 64 degrees, the angle that I know, is adjacent, which is 8 over the hypotenuse, and I'm just going to call that little b, just to give myself a variable again. So we're going to find the cosine of 64 degrees, which is 0.4384 equals 8 over b. Multiply both sides by b, so 0.4384b equals 8. And then finally divide, so 8 divided by 0.4384, b would be 18.25. 18.25. So I think I look at my triangle carefully. I see that I have all of those missing side lengths calculated, and now what I need to do is find the missing angles. Well, I've already found one of them just because I used that in the earlier problem. We know that angle DAC, the measure of angle DAC is going to equal 42 degrees. And I calculated that based on 180 degrees being in a triangle. I know that angle, let's see, ACD has to be a right triangle, ACD, and so that measurement would be 90 degrees. And then finally, what's the only other missing angle I need is this one up here, which would be angle BAC, and I'm going to go ahead and calculate. Again, that triangle has 180 degrees, so 180 degrees minus the 64 degree angle that I know, minus the 90 degree angle that I know, that measurement is going to be 26 degrees. So that part was pretty easy to just go back and use the idea that we've got right angles and triangles that equal 180 degrees to find those missing angles. So let's look at a little bit more specific problems. In this first problem, we've got a more real-life example. It says a radio tower is tethered to ground by 2 ropes. The ropes are attached to the ground at points G and F. G is 60 feet from the base of the tower, so I'm going to, the first thing, go ahead and write that in. This length is 60 feet. And the angle formed at G, so this angle right here, is 21 degrees. The angle formed at F is 32 degrees, so I'm going to also write that in. How far apart are points F and G? Well, it would be nice to go right to this length here because that's the length that I need, but that's not a right triangle, so I can't use trig to be able to figure that out. So what I'm going to have to do is I'm going to have to use both this larger triangle, and I'll outline it in red, and the smaller triangle, and I'll outline it in yellow, so that I can calculate those two lengths, or at least one of those lengths, and then subtract it from the 60 feet. So let's look at the big red triangle first. In this big red triangle, I know an angle, 21 degrees, and I know this whole side length right here is 60. What I would really like is this vertical length so that I can use it for the smaller yellow triangle. So what do I know? I know the angle, and I need opposite, and I have adjacent. So again, if I wrote down SOHCAHTOA, I know that opposite over adjacent is tangent. So we're going to go tangent of 21 degrees equals the opposite, that's the one that I don't know, I'll call it x, over adjacent, which is 60. So we're going to do the tangent of 21 degrees, and that is 0.3839 equals x over 60, and then multiply both sides by 60, so 0.3839 times 60 is 23.034. So that's this length right here, 23.034. Now I'm going to switch to the yellow triangle, and now I know that vertical side, so I can find this horizontal side, which will allow me to subtract that from 60 so that I get the side length that I need. So in relation to this 32, I have opposite, and I need adjacent. Well, that's tangent again. So tangent of 32 degrees equals the opposite over the adjacent, and I'm going to call that y. So the tangent of 32 degrees is 0.6249 equals 23.034 over y. I'll multiply both sides by y, so 0.6249y equals 23.034, and then I'll divide. So y equals 36.86. So now that I have this length right here, I can just subtract it from the total length to get the distance between G and F. So 60 minus that 38.86 equals 23.14. So that distance is 23.14 feet. All right, let's look at this rectangle. So there's going to be a few things that you need to remember about geometry. In a rectangle, the diagonals, which are these two, are equal. They're also cut in half by that bisector. So it says PQRS is a rectangle, and that's important for us to know because rectangles have right angles. QR is 16, so I'm going to go ahead and label that on my picture. An angle SQR, so let me do that in a different color. SQR is 28 degrees. Find each length. The first thing I want is SR. So if I look at this green triangle, in relation to this 28 degrees, I need opposite and I have adjacent. Well, again, that's tangent. So we're going to go tangent of 28 degrees equals the opposite, I don't know, I'll call it x, over the adjacent, which is 16. Tangent of 28 degrees is 0.5317 equals x over 16. 0.5317 times 16 is 8.51. So that length is 8.51. I'm going to go ahead and jot that in my diagram as well. The next thing I need is PT. Well, PT is half of the diagonal, and the diagonal should be equal. So in the same green triangle, if I find the hypotenuse, PT should equal ST, which is just half of that diagonal. So let's go ahead and use that green triangle again. In relation to 28 degrees, I know for sure adjacent, and I need hypotenuse. So adjacent over hypotenuse is cosine. So let's go ahead and do cosine of that angle, 28 degrees, is adjacent, which is 16, over that hypotenuse, which I'm going to call y. Cosine of 28 degrees is 0.8829 equals 16 over y. Multiply both sides by y, so 0.8829y equals 16, and then divide, so 16 divided by 0.8829 is 18.12. Well, that's that whole diagonal, but I only want half of it, so I'm going to divide 18.12 by 2, which would be 9.06. So that's the length of half of that diagonal. The last thing that I want is the measure of angle QTR. So let's find QTR. QTR. So that's that angle up here. Well, if I look at the relationships of the angles in this rectangle, this angle is the same thing as this. And I know that because those rectangles are symmetrical. So all I need to do then is figure out what that angle is. Well, I know that angles in a triangle add up to 180. So I'm going to take that 180 and subtract the 28 that I know for sure, in addition to the other angle that I know, which would be 28. So 180 minus 28 is going to be 124. So the measure of angle QTR equals 124 degrees. So these problems really aren't that hard when you're able to use trig functions. You'll just need to use a little bit of creativity to figure out what angles and what sides you either have or need in order to solve the problems.